Hello, this is Nitin Dwivedi. I'm Tech System from IIPS. This assignment is about system flowcharts of the subject system analysis and design. In this video, we will look about the system flowcharts, its use, and how do we use it. So, what is the purpose of the system flowcharts? The purpose of the flowchart is to document a concrete or physical model and to visualize them in the graphical form. The system's discrete physical components, like its programs, procedures, files, reports, and etc. And what are the strengths, weakness, and limitations of the flowcharts? Definitely, there are a lot of strength of the flowcharts. It shows how the system major components fit together and how they interact with each other. And the system flowchart is an excellent tool for summarizing great deal of technical information about any existing system. System flowchart can also be used to map any hardware system, and they are valuable as project planning and project management. They are same value, they hold the same value as that of project planning and project management. Using system flowcharts as a guide, we can easily go through our project, entire project. We can look at this, we can analyze it, we can visualize it. There are also few weakness, or we can say limitations of flowcharts also. The system flowchart symbol represent physical components, and the mere act of drawing can imply physical decision. So as a result of that, system flowcharts are poor analysis tool. You cannot analyze, you can analyze the project, but you cannot analyze tool very in a good way. So because the appropriate time for making physical decision is after analysis, so it's not it might be misleading sometimes because it uses the shapes and all that. It's so might be you need to have the good knowledge of system flow charts. It's a theoretical knowledge that which shapes indicates that and what is the meaning of that. So that's not exactly true, exactly helpful. Okay, but and the next we have that how do we draw this, how do we make the system flowcharts, how to take input and etc. So the first step in drawing a system flowchart is to identify the system physical components by using such tools as automation boundaries. And some analysts or some professionals prefer to use physical data flow diagrams to document physical alternatives. First they draw the physical data flow diagrams and then uh, they use the physical data flow diagrams to document these physical alternatives. The complete system flowchart is sometimes used to support the project planning stage. So the concepts that how do we draw the system flowchart or system flow diagram, it is very easily it is easily visualized in the graphical form. So flowcharting symbols and conventions. On system flowchart, each component is represented by a symbol that visually suggests its function. Like like we have had the simple flowchart of an algorithm. We have different uh, shapes and symbols for every type of action. We have different symbols for we have had different symbols for input for the displaying the message. So that's we have had in the basic flowchart. In the same way we have here also a given flow line might represent the data flow, control flow, or hardware interface. By convention, the direction of flow is from top left to bottom right, from up to down, and arrow head must be used when the convention is not followed. So if the arrowheads are not there, then by convention it is considered that we the direction of the data flow is from top to bottom only. Arrowheads are recommended even when the convention is followed, because they help to clarify the documentation, because it gets simple for viewer, for analyst to simply in a first view they can identify that what is the data flow of in the system flowchart. So this is the figure for the different shapes we use in the system flowchart designing. For the process, we use the square. For any magnetic tape or sequential file, we use the symbol like circle and the little bit that arc. And predefined process, we will look for the what is predefined process in the next slides. And these are the different things that we display. We have this different shapes. So different shapes are used to uh, detect that what is this process, and small circle is used as a page connector, because flow charts might be large, that so large that it might not fit into a single page. So to we can need more than one pages to draw those flow system flow chart of a project. So to connect the flow charts made in different pages, we use this small so predefined process, as we have seen, as what are the predefined process. Like the flowchart for a complex system can be quite large, as I have told you that our project or our system is very large. So if we draw its system flowchart, then it might be very, it can be very large. So its predefined process is we have encapsulated it. We have wrapped it in a entire big process into a single box, and then we elaborate that process, that it's a part of that flowchart in a different section. So an off-page connector symbol can be used to continue to flowchart sequence, but multiple page flowcharts are difficult to read. Yeah, of course, because system flowcharts are might be large, as I have told you, but an off-page connector, that small circle, can be used to connect it. But we usually try that our flowchart can be adjusted in a single page only. So do this, we predefined processes are quite helpful for us. A good approach is to draw a high-level flowchart showing a key functions, that the main functions as predefined process, and then explore these predefined process into appropriate level on the subsequent pages, on different further pages. This is predefined process. Like we have the check shipment. The check shipment is the predefined process. We will uh, explode it, we will fragment it into the different different section of page in the subsequent pages later on. Just now we have wrapped it in a single process and named it as check shipments, so that our flowchart, our system flowchart, can be compacted, can be minified, can be minimal. So and so this is the now the predefined process that we have just seen in the previous slide, that there is a check shipment process. This is the predefined process, and here we have exploded that predefined process. Now the another way of to whole design this whole system flow chart, and then connect it to this. So this flow chart would be very a large, would be very handy to manage and very handy to read. So it would be very complex flowchart. So to reduce complexity, this whole this whole flowchart, this whole system wrapped up into a single process, and we named it as check shipment. So this is how we represent predefined process in this way, two lines. Okay, so the supported documentation, it's a brief summary that each symbol on a system flowchart represent a discrete hardware component and either software data. A process can represent a computer, an online storage symbol represent disk or drive, printer symbol stands for printer, and these are different symbols also that we have seen that are used in the system flowcharts. The key terms that we saw in these presentations were system flowchart, of course, system flowchart that you must have been understood that what is system flowchart. It is the tool for documenting a physical system so that we can analyze and visualize it. And the predefined process, it is on a system flowchart, a high level process which can be broke down into the many low level processes which can be expanded, that is more fully documented in a separate and a lower level flowchart. So this is the predefined. So hope you must have understood both of these key terms, system flow chart and predefined process, how the predefined process is used in the system flow charts. And I have took the reference of this book. Thank you. Thanks.